Hello children, welcome back to the mathematics class. Hope you are doing well. Dear children, in our last videos, we have studied about linear equations and some verbal questions on that. How to solve a linear equation in one variable and how to find the value of the unknown variable. That's what we have seen in our last videos. Today we will learn a new chapter about rational numbers. Okay, let us come back with the linear equations what we have studied. See, in the last class we have studied some linear equations of this form. For example, x plus 5 is equal to 8. We have studied x plus 5 is equal to 8. When this equation becomes true, what is the value of the x here? Very easily you can say, how much if you add to this 5 you will get 8. If you add 3 to this 5 you will get 8. Therefore, the value of x is equal to 3. So, 3 plus 5 is equal to 8. So, value of x is equal to how much? 3. See this 3. Here, see here. These numbers are positive numbers. This is a positive number. These numbers are called natural numbers. So, natural numbers, about natural numbers you have studied. What do you mean by natural number? Natural number. See, natural number, it is represented by the symbol n. Set of natural numbers is equal to what? Set of natural numbers starts from 1, 2, 3, like this, 4, 5, like this, it continues. So, the natural number which starts from 1, 2, 3, 4, 5, 6, like that. These are also called counting numbers. These numbers we will use for counting the objects. Is it? Therefore, we have studied about this in our previous classes about natural numbers. See, so these numbers are called natural numbers. Now, I will write another linear equation. Say x plus 7 is equal to 7. What is the value of x here? When this equation becomes true, what value of this x makes this equation true? See, here x plus 7 is equal to 7. What if you add this 7, you will get this 7. If you add, nothing is there to add this 7 to get 7. So, value of x is 0, isn't it? So, if you add 0 to this 7, you will get 7. Therefore, this 0, value of x is 0. But 0 is not, comes under the set of natural numbers. So, to the natural numbers, if you add 0, so if you add 0, see, then to the natural number 1, 2, 3, 4, 5, 6, like this, to this one extra digit is there, that set of numbers are called whole numbers. You have studied. So, whole number starts from 0, 1, 2, 3, 4, like that, all other numbers. So, here whole numbers, in the set of whole numbers, only one digit extra, that is 0. Then all natural numbers only. So, natural numbers begin from 1, whole numbers begins from 0. So, in whole number, which is the least whole number? 0 is the least whole number. Which is the least natural number? 1 is the least natural number. Okay. So, 1, 2, 3, 4, 5, 6, these are counting number or natural number. 0, 1, 2, 3, 4, 5, 6, like that. So, all natural numbers are whole numbers also. But all whole numbers are not natural number. Why? Because all whole numbers here 0. 0 is not a natural number. It is a whole number. Okay. Yes. So, that is what we have said. Now, I will write one more linear equation. Say 5x is equal to 6. 5x is equal to 6. What value of x makes this equation true? 5x is equal to 6. See here, how to solve this equation? 5x is equal to 6. Therefore, x is equal to 6 by 5. So, whether 6 by 5 is equal, if you carry this 5 here, it goes to the denominator. Therefore, x is equal to 6 by 5. Is it? Therefore, what is this? Whether natural number or whole number? It is not a natural number, it is not a whole number. See, 6 by 5, or if the numbers are in this form, or in general if you write it as in the form of P by Q or A by B, whatever it may be, like this, if the numbers are in this form, then that numbers are called natural numbers. So what do you mean by natural number? Natural number, the number which can be represented in the form of P by Q are called rational numbers. Okay, that it may be positive or negative. Understood? Positive or negative. See, in addition to this, one more I am write. Look at this. X plus 3, x plus 6 is equal to 5. X plus 6 is equal to 5. Here, look at this equation. X plus 6 is equal to 5. What value of x makes it 5? So, plus 6, some to a number if you add plus 6, you will get 5. The smaller number. So, it must be a negative one. So, what is the value of x? X is equal to 5. If you carry the 6, it becomes minus 6. 5 minus 6 is equal to not 1, it is minus 1. See, minus 1. So, value for this x minus 1 makes this equation true. Therefore, minus 1. So, this number, it is called, it is not a natural number, whole number. This type of number comes under integers. You have studied integers. So, integers starts from all whole numbers, natural number, etc. And this side, if you come back, it is minus 1, minus 2, minus 3, minus 4 to the left, and to the right 1, 2, 3, 4 like that. So, all negative numbers 0 and all natural number are positive numbers. See, 0 is not a negative or positive number. It has no positive or negative sign. Okay. Therefore, all positive numbers, negative numbers, including zeros are called natural integers. Okay. Other than this, like this negative, this is an integer. Minus 1 is an integer. So, to write, you know, I told in my last rational number means a number which can be represented in the form P by Q. So, therefore 5 by 6 or 8 by 7, these are all rational numbers. So, if the numbers are written in this form P by Q, in general how we can define a rational number? Rational number means a number which can be written in the form of P by Q. Okay, P by Q, if you write, it is called a rational number. If it is not possible to represent in the form of P by Q, they are called, no, it is not a rational number. They are called irrational number. Another form is there. Okay, now what should be there? Is it a rational number? Yes, this is also a rational number. Whatever it may be, it may be positive or negative, whatever it may be. See, it is minus 6. P is equal to minus 6 here. Q is equal to 7. That's all. So, it may be minus, plus, whatever it may be. P or Q may be plus or minus, whatever it may be. Okay. Therefore, rational number means a number which can be written in the form of P by Q. Okay. They are called rational numbers. Now, let us learn in this chapter. We are going to learn about rational numbers and some of the whole numbers, natural numbers and their properties. Natural numbers or whole numbers, for example, whole numbers, natural numbers also whole numbers. Natural numbers are also whole numbers. Natural numbers, integers and rational numbers. About this you are going to learn, and some of the properties of whole numbers, integers and rational number you are going to learn. See, so properties of whole numbers, integers and rational numbers you are going to learn. In that first one is about closure property. First property is closure property. Now let us apply that closure property for this whole number. Whole numbers. You know, whole numbers include what? Tell me, whole number W is equal to 0, 1, 2, 3, like that it continues. 1, 2, 3, 4, 5, 6, 7, 8, like that it continues. Integers includes minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, like that it continues like that. To the right hand side it continues, and to the left hand side also it continues. and rational numbers can be written in the form of p by q. It may be minus or plus. Minus, p may be minus number, negative number or positive number. Now closure property. Closure means for all a and b, or let us apply for whole numbers. See, if you apply that one for whole numbers, let us apply for whole numbers. See, what are whole numbers? 0, 1, 2, 3, 4. These are all called whole numbers. Now, if we add any two whole numbers, let us consider two whole numbers. Say 1 and 6, or 4 and 6. Let us take these two numbers. Say 4 and 6. If we add these 4 and 6, what happens? If we add these 4 and 6, 4 and 6 is equal to 10. Now, this 4 is a whole number, 6 is also a whole number, 10 is also a whole number. Correct? Therefore, if you add the whole number, then the result is also a whole number. Whatever may be, any whole number if you take. If I take 8 plus 2, what is the answer? 10. 8 plus 2, 8 is a whole number, 2 is a whole number, 10 is also a whole number. Therefore, addition property holds good. Or we can say whole numbers are closed under addition. Therefore, in general we can say for all a and b are whole number, 10 is also a whole number. Then a and b are whole number. Then a plus b is also a whole number. Therefore, a for all a, b are whole numbers. Then a plus b is also a whole number. Therefore, addition property holds good for whole numbers. Or we can say whole numbers are closed under addition. Next, let us move on to the subtraction. What about for subtraction? Let us subtract two whole numbers. Let us consider two whole numbers. Say 7 minus 3. What is the number? 7 minus 3. What is the answer? 4. Yes, 7 is a whole number, 3 is a whole number, and 4 is a whole number. Yes, 7 minus 3 is equal to 4. Yes, it is possible. But 3 is a whole number. I will subtract 7 from this 3. What is the answer? 3 minus 7. 3 minus 7 is equal to minus 4. But minus 4 is not a whole number. Isn't it? It is not there. Minus 4 is not there in the set of whole number. Therefore, sometimes subtraction is not possible for whole number. The answer for a and b are whole number, then a minus b may or may not be a whole number. Here it is whole number, but here it is not a whole number. Therefore, for subtraction, closure property holds not good for whole number. Subtraction is not holds good, or we can say subtraction is not closed under not closed for whole number. Subtraction is not possible for whole number. Subtraction is not possible. Why? If you subtract any two whole numbers, then the answer may or may not be a whole number. The result may or may not be a whole number. Why? That example you have given. For example, 2 minus 5. 2 minus 5 is equal to minus 3. 2 is your number, 5 is your number. If you subtract it from 2, you will get the answer minus 3. Minus 3 is not a whole number. Therefore, subtraction is not holds good for whole numbers. Okay. Next, multiplication. Let us multiply any two whole number. 5 into 7. 5 into 7 is equal to 35. Look at this. 5 into 7 is equal to 35. 5 is a whole number. 7 is a whole number. The product is also a whole number. Therefore, for all a and b are whole number, then a into b or ab is also a whole number. Or 7 into 5. If you reverse the order, 7 into 5. What is the answer? 7 into 5. 7 into 5 is also it is also 35. So 5 minus 7 is not equal to 7 minus 5 as subtraction. But 5 into 7 is 35. 7 into 5 is also 35. Therefore, if a and b are whole number, its product is also a whole number. Therefore, multiplication is possible. Multiplication is possible, or multiplication is closed. Multiplication is closed for whole numbers. Okay, multiplication is closed for whole number. It is possible. Addition is possible. Multiplication is possible. Subtraction is not possible. Now let us check for division. I will take two whole numbers. Say 4 divided by 8 divided by 4. 8 divided by 4. What is the answer? 8 divided by 4 is equal to 2. Is equal to what? 2. 8 divided by 4 is equal to 2. Okay. Here 8 is a whole number. 4 is a whole number. 2 is also a whole number. Okay. It's possible. Here it is possible. But 4 is a whole number. If you divide it by 8, what is the answer? 4 divided by 8 is equal to 1 divided by 2 if you simplify. But 1 divided by 2 is not a whole number. If you divide any two whole number, then the quotient may or may not be a whole number. Because see the example, 8 divided by 4 is equal to, yes, it is a whole number. But 4 is a whole number, 8 is a whole number. If you divide 4 by 8, the answer is 1 by 2, or 1 by 2 means 0.5. See, 1 by 2, it is not a whole number. It is not comes under whole number. Therefore, division is not possible. Division is not possible. Or you can say, for whole number, division is not closed, or division is not closed for whole number. Okay, division is not possible. Therefore, we can say, for whole number, for closure, for whole number, addition and multiplication are closed, but subtraction and division are not closed. It is not possible. Okay, this is for whole number. Now let us apply it for integers. For integers, what happens? You know what are integers? All negative number, positive number along with 0 are called integers, isn't it? What happens this closure property for integers? See, let us add two integers, any two integers. See, minus 3 plus 2. I will add. What is the answer? Minus 3 plus 2. The answer is minus 1. Whether minus 3 is integer, 2 is another integer, minus 1 is also integer. Or if you reverse order, whatever it may be. See, a positive number 5 plus minus 7. What is the answer? 5 plus minus 7 is equal to minus 2. Answer is minus 2. Or 3 plus minus 1. What is the answer? 3 plus minus 1 is equal to plus 2. See here, if we add any two integer, whether it is positive or negative, if you add any two integer, what the result you will get is also an integer. Therefore, addition is possible. So, addition is closed. Addition is closed for integer. It is possible. Why? If we add any two integer, the result is also a integer. Yes. Next, what about subtraction? See, if you subtract, see, minus 3, one integer, minus plus 4. What is the answer? Minus 3 minus 4 is equal to minus 7. The minus 7. Here minus 3 is an integer, 4 is an integer. The answer minus 7 is also an integer. Or whatever it may be, the integer, it may be positive or negative. For example, 8. 8 minus 3. 8 minus minus 3. 8 minus of minus plus 3. The answer is 5. Answer is 5. See, here 8 is an integer, minus 3 is an integer, the answer 5 is also an integer. Isn't it? Therefore, subtraction is also possible. It is also closed for integer. Subtraction is also closed. But here, for whole number, subtraction is not closed. But for integer, subtraction is also closed. Now what about multiplication? If you multiply any two integers, for example minus 3 and minus 2, what is the answer? Minus 3 into minus 2 is equal to plus 6. See, the product is plus 6. Whether minus 3 is an integer, minus 2 is an integer, plus 6 also an integer. Or suppose 2 into minus 5. What is the answer? 2 into minus 5, minus 10. The answer is, the product is minus 10. See, 2 is an integer, minus 5 is an integer, minus 10 is also an integer. Therefore, if you multiply any two integer, then the product is also an integer. Therefore, multiplication is also possible. For integers, multiplication is closed for integers. Next, division. 8 divided by 4. Or for example, any two. Minus 3 divided by minus 1. What is the answer? Plus 3. minus 3 divided by minus 1 is equal to plus 3. It's an integer. Okay, it is possible. See, I will divide another integer. Say 2 divided by 2 divided by 4. What is the answer? 2 divided by 4. 2 divided by 4 is equal to how much? 2 divided by 4 is equal to 1 by 2. 1 by 2. 1 by 2 is not an integer. 1 by 2 is not an integer. Therefore, division is not possible for all integers. Division is not possible. It is therefore division is not closed for integers. So, addition, subtraction and multiplications are closed for integer, but division is not closed for integer. See here, for whole numbers, addition and multiplication only closed for whole numbers. Subtraction and division not closed, but for integers, addition, subtraction and multiplications are closed for integers. Division is not closed for integers. Okay, division is not holds good for integers. Next, let us come to the whole number. Rational number. What about rational number? For addition, if you add any two rational number, see 1 by 2 is a rational number. If you add another rational number, say 1 by 2, the answer is 2 by 2. 2 by 2 is equal to 1. See, 1 by 2 plus 1 by 2 is equal to how? How to add this? 2 is LCM. So 1 plus 1 is equal to 2 by 2. So 2 by 2 is equal to 1. See, 1 by 2 is a rational number. 1 by 2 is another rational number. The sum is also a rational number. Whatever it may be, it is a rational number. If I add, say, 5 by 2 plus minus 3 by 4, minus 3 by 4. 5 by 2 is a rational number, minus 3 by is also a rational number. What is the sum? See here, 4 is a LCM. 4 means you have to multiply by 2. 5 into 2. 2 into 2 is 4. 5 into 2 is 10. Plus 4 into 1 is 4. Minus 3 into 1 is minus 3. So 10 plus minus 3 is equal to 10 minus 3 is equal to 7 by 4. Look at this. Look at this. See here, if you add 5 by 2 to minus 3 by 4, 5 by 2 is a rational number, minus 3 by 4 is a rational number, the answer 7 by 4 is also a rational number. Therefore, for rational number, addition is possible or addition is also good for rational number. Therefore, addition is closed for rational numbers. Now, what about subtraction? For subtraction also like that. See, if I subtract, see, 7 by 3 minus 3 by 6. 3 by 6. If you subtract, what is the answer? 6 is the LCM of 6 and 3 and 6. And to get it, you have to multiply by 2. So 7 into 2 is 14 minus 6 into 1 6, 3 into 1 3. So answer is 11 by 6. So here 7 by 3 is a rational number, 3 by 6 is another rational number. The answer, if you subtract these two rational numbers, then you will get 11 by 6. 11 by 6 is also a rational number. Therefore, for rational number, subtraction is possible. Okay, so subtraction is closed for rational number. It is possible for all A and B is a rational number, then A minus B is also a rational number. It is possible. Then multiplication. Let us multiply. Minus 1 by 3 into minus 3 by 4. What is the answer? Here 1 by 3 into minus 3 by 4 is equal to 1 into minus 3 is minus 3. Direct multiplication. Numerator and denominator to the denominator. 1 into minus 3 is minus 3, 3 into 4 is 12. So here 1 by 3 is a rational number, minus 3 by 4 is a rational number, and minus 3 by 12 is also a rational number. Okay, therefore multiplication is possible. If you check using any other rational number, then you will get the product as a rational number only. Therefore, rational numbers are, or multiplication is closed for rational numbers. Okay, you can use any instead of this rational number. If you use any rational number, the product is also a rational number. Now for division, what happens? For division, see how to divide 2 by 5 divided by say 2 2 by 4. 2 by 4. If it is like this, what happens? 5 by 2 into 4 by 2. The answer is like this. 2 ones are 2, 2 twos are 4. So, answer is 10 by 2. The answer is 10 by 2. Here 5 by 2 is a rational number, 2 by 4 is a rational number, 10 by 2 is also a rational number. We can say 10 by 2 is also a rational number. But for some cases it is not possible. When it is not possible, for example, 3 by 5 divided by 0, say for example 5 by 0. Suppose if it is like this, now what happens is, here if it is like this, 0 by 5 is not defined. In the previous class we have studied, it is not 0. See, for example, 0 by 5 is equal to 0. Answer is 0. 0, 5. If 0 is in the numerator and any number is in the denominator, the answer is 0. But 0 is in the denominator and any number in the numerator, whatever it may be, let us consider it as 7, for example, 7 or minus 7, or it may be positive or negative. If it is 0 in the denominator, there is no specific answer. The answer is not defined. The answer is not defined. See, remember, if 0 is in the denominator, the answer is not defined. Therefore, there is no specific answer, no exact answer for that. Therefore, in general, we can say A divided by 0 is not 0. It is not defined. ND. You can say it as not defined. Therefore, division is not possible, because in all cases division is not possible. Therefore, division is not possible for division is not closed for rational number. Therefore, only addition, subtraction and multiplications are closed for rational number. Division is not closed for rational number. Let us come back. See, for whole numbers, addition and multiplication are closed for whole number. Subtraction and division are not closed for whole numbers. Here, for integers, addition, subtraction and multiplication are closed for integer. Division is not closed for integer, and for rational number, addition, subtraction and multiplications are closed, but division is not closed for rational numbers. Okay, this is about closure properties of rational numbers. In another class, we will learn some more properties of rational number. It's enough. So today what we have studied about, we have recalled about natural numbers, whole numbers, integers and rational numbers, and closure properties of whole numbers, integers and rational numbers we have studied. Okay, so it's enough for today's video. In our next video we will learn some more properties of rational numbers. See you in our another video. Okay, thank you.